Can you spell the odd one out for this color puzzle? Or what about this one? I'll give you guys a few seconds to try. Now what about this one? Tricky, right? There's no secret method to solve any kind of these puzzles. There's no way you can look at a reference photo and try to copy it. There's no way like cards where you can hide cards to try to cheat your way to success. These puzzles are so challenging because they're based off of pure perception. Now look at these two cups of purple liquid. Can you tell me which one is darker? This one's darker, and if you guessed right, good job. But did you just guess, or do you know? How can we prove that this one is darker and not this one? It all starts with chemistry and visible light. Visible light is a type of electromagnetic energy. Some other examples would be radio waves or X-rays. And electromagnetic energy is emitted in quantified form, meaning light and energy exists in packets or photons. And for example, in this photo, the more photons, the brighter the light, and vice versa. Specifically, the visible light is when electrons jump or transition to different energy levels, compared to like microwave radiation, when water molecules spin very fast that cause heat. Here we have the wavelengths of visible light, where every single color corresponds with a different wavelength in nanometers. The electrons that move faster have a shorter wavelength, and the electrons that move slower have a longer wavelength. The wavelength spectrum actually goes a lot farther, but the human eye can only see the visible light. Let me introduce to you the spectrophotometer. It analyzes the intensity of the color in a solution and ultimately determines concentration. First, you insert a small sample of the solution into the machine. The machine shines a light source onto the colorimeter, or a lens, and focuses the light onto a monochromator, called a prism. The prism splits the light into different wavelengths, and it shines onto an adjustable slit called a wavelength selector. So a single wavelength or light color is selected and shown through. The light shines onto a solution, and the incoming light gets passed through and measured, called the absorbance value or optical density. The machine will provide us with an absorbance spectrum, with the wavelength that's the x-axis and absorbance on the y-axis. And to optimize our data, we will use the wavelength with the highest absorbance and the less interference of other substances. In chemistry, concentration measures the amount of solute dissolved in solution. And for this example, the more concentrated one has more solute dissolved in it. Now with our given information, we will use Beer's law that gives us this formula. We have absorbance is equal to the molar absorptivity times path length times concentration. And using simple algebra to rearrange this, we will get this formula. Using hypothetical values, I've calculated two different concentrations, 1.14 molar and 1.28 molar. Can you correctly identify which one would be for which? And if you've correctly identified it, congratulations. We've officially proved why one substance is darker than the other. This is super important in many STEM fields like engineering, biology, medicine, so many other, because we can identify unknown substances. And I hope the next time you play one of these games, you think of this spectrophotometer like I do.